Assalamualaikum and a very good day. So now we are going to a new topic, which is matrices. In this matrix, maybe it is much more easier compared to the previous topic. So we start here with the review of what you have learned before this. We start with the introduction to know what kind of the matrices, to learn about matrix equality, and then we will go to the next video for operation of matrices, matrix addition and subtraction, scalar multiplication, and also matrix multiplication. But for week 10 part 1 video, you will learn just introduction, type of matrices, and also matrix equality. Now we go to the introduction of the matrix. What does it mean by the matrix? You have learned before this, you always see this form. So this one we call it as matrix. It is a rectangular array of numbers arranged in rows and columns and enclosed in parentheses or brackets or braces. So here, now we enclose this one in bracket, and then we can see this one, we call it as row, and this one we call it as column. And here we can see we have element A11, A12, A1J, and so on. So all these A we call it as elements of the matrix. And then if you see here you have M, N, means that this matrix is M times N dimension. So this M, N will give a dimension of the matrix. Means that here, if we see generally a matrix A with M horizontal rows, this one, and N vertical columns, we see we have N numbers of columns. It is denoted as M times N. So this one is dimension of the matrix, and that matrix is given by this matrix. And here Aij, in this matrix, we call it as elements at I row and J column. And the order or dimension of a matrix here is given by number of rows and then times number of columns, which is here M times N. And then we go types of the matrices. We have first row matrix. Row matrix, a matrix consisting a single row, just a single row, or a matrix with 1 times n. If you still remember, this one is referred to row and this n is referred to column. So only one row and column can be any numbers. This is example of row matrix. And then we go to the column matrix. It is opposite of row matrix because for column matrix is consisting a single column matrix with m times n. So here row can be any number. This one is row, but column should be equal to 1. So these are the example of the column matrix. Now we go to a square matrix. A square matrix is a matrix with an equal number of rows and also column. Means that leading diagonal of square matrix is the diagonal containing the number of the upper left and also lower right. So this is leading diagonal, and here is upper left. This 3 is lower right. Same with this one. We have here this one is upper diagonal. Sorry, this one is leading diagonal, and here is upper diagonal, and this 302 is lower right. Here it's mentioned number of rows and columns should be equal. Means that if you see here we have 2 rows times 2 column. This one 3 rows times 3 column. When we have number of row equal to number of column, we call it as square matrix. And then we have null matrix. Null matrix means that all elements are 0. So you see here you have null matrix, which all elements here are equal to 0. Now we go to identity matrix. Identity matrix means that leading diagonal is equal to 1 and the remaining elements are 0. In this case, we can see here our leading diagonal all equal to 1, and we have other values or other elements are 0. So we call this matrix as identity matrix. Then we have diagonal matrix. Diagonal matrix refer to a square matrix in which all the elements are 0 except for diagonal element. Means that here, for identity matrix, you have leading diagonal equal to 1. But for diagonal matrix, our leading diagonal here is not necessarily 1. It can take any value, but for the other elements, it should be equal to 0. Then we go to a symmetric matrix. It is a square matrix such that the transpose of matrix is equal to the matrix. Means that here you have B transpose equal to B. So in this case, it should be in terms of number of column. Number of column should be equal to number of row, because here it is a square matrix. And we have another additional condition, that is matrix it transpose equal to its matrix. Means that here you can see if I transpose this one, I still get the same matrix because this element equal. Also this one 7, here 7, here 2, it is equal to this element, 0 equal to this element. When you transpose this one, you will get back that matrix. And then we go to upper or lower triangular matrix. Okay, a square matrix where all the elements below or upper the main diagonal are zeros. Means that here, for upper triangular matrix, it means below main diagonal or below leading diagonal elements equal to 0. Also for this one, means that these two example is upper triangular matrix. For lower triangular matrix, for example, you will have here 1, 2. Here you have element, but this upper diagonal elements are 0. And for this one, if I give one example of the lower triangular, for example, we have 2, 8, 4. 0, 0 is here, but here is -3, for example, 1. And then here, for example, 2, 1, 4. So this is example of lower triangular matrix. It is opposite of upper. Upper means that below values of main diagonal are 0. But for lower triangular matrix, it means that upper value of main diagonal are equal to 0. So we go now to the example 1. The question asks us to classify the following matrices according to the types of matrices. Based on this matrix, which one is row matrix? If you still remember, row matrix refer to a row matrix or a matrix with row number should be equal to 1 times n. So for column, it can take any value. In this case, we can see that this C is a row matrix. A square matrix means that a matrix which is have m times m, that is number of row equal to number of column. So in this case, we have here A and B as a square matrix. And then symmetric matrix means that should have here m times m, it is equal for row and column. And then when we transpose that matrix, for example, B transpose, it is equal to its matrix. Means that here in this case, only D fulfill this condition. And for D is lower triangular matrix. If you still remember lower triangular matrix, all elements above main diagonal should be equal to 0. So here we have B as lower triangular matrix. And now we go to this example 2. We need to classify the following matrices according to the types of matrix. For a column matrix, So here we can see clearly it is R. Identity matrix, it is P. Diagonal matrix, what does it mean by diagonal? The element at main diagonal, we have the elements, but other than that should be equal to 0. So it is Q. Symmetric matrix, you have a matrix in square matrix, and then when you transpose, you should get back that matrix. So the answer for this one is T. Upper triangular matrix, it is S, means that the element below this main diagonal is 0. So this S is upper triangular matrix. Now we go to equal matrices. What does it mean by equal matrices? Two matrices are said to be equal if they have same size. Same size here means that two matrix, for example, the first matrix have size 3 times 2, and the second matrix also need to have size 3 times 2, and their corresponding entries are equal, means that here Aij should be equal for both matrix. So this one we can say that there is some example here for this equal matrix. We can see here -4, and then for this one -5 plus 1 you will get -4, so it is equal the element. Here also this one also 2 0, so for the first row elements are equal. For the second row also you have same element, means that for this case entries are equal. Then we check for its size. This one have size 2 times 3. This one also 2 times 3, means that here the size equal, so it is equal matrix. This matrix is not equal because this one is 2 times 3, but this one is 3 times 2, means that its size is not equal. And then this one, the element for this one is not equal, although it has same size, so it is not equal matrix. Next, we go to this example 3. The question asks us to find the values of x, y, and z if we have this kind of matrix. So now this matrix is equal matrix. How to compute the value of x, y, and z? We make the element equal. This 2x should be equal to this -2. This y minus 4 should be equal to 7. And this z over 5 should be equal to 15. So 2x equal to -2 imply that x equal to -1. And then y minus 4 equal to 7 imply that y equal to 11. Next, z over 5 equal to 15. So this one imply that z equal to 75. So this is the answer for x, y, and z. Now we come to the end of this video. Thank you class for your attention and see you in the next